So in this video I'm going to be doing 4.1 and 4.3 together. So for the polynomials only, so 4.1 and 4.3, which are the extremas and whether it's increasing and decreasing over a certain interval. Now this might be difficult for some of you, so I'm going to take this literally step by step. Okay, so let me start with my first question. Okay, so here's my first question. Now, the first thing, now obviously I'm asked to find my extremas, which are my local maximum, local minimum, and like where the function is increasing or decreasing. So let me start with my first step. Now the first thing you're gonna do is not really related to the solving, but we are going to do it anyway. Alright, we have to say the step. So first thing you're going to say is that f is continuous on the closed interval of the domain that they gave you. So continuous always over the closed interval and differentiable over the open interval. Now, the doctor said this is very important, so make sure you write this on the exam before you start. So this is my first step. My second step is going to be finding f prime of x. So I need to find my derivative. The derivative of f of x here is going to be 4x cubed minus 4x. That's my second step done. Now, my third step is that I need to find something called my critical points. Now, how do I find my critical points? Since I'm solving here, it's a polynomial. To find my critical points, all I need to do is to make f prime of x equals to 0. So for now, the important things we have are here. So for the critical points, f of x is equals to 0, and we need to find f prime of x. So these are the important steps to solve. So let me do just that. I'm going to take 4x cubed minus 4x. I'm going to make it equals to 0. Now, you don't really have to simplify it on the calculator. You can do the mode setup, but instead of 5, 3, you're going to put 5, 4, since it's a cubic function. And now let me see my values. I'm going to get x1, which is going to be 1. I'm going to get x2, which is negative 1, and I'm going to get x3, which is 0. Now my fourth step is that I need to check if the x values belong to my domain. So my domain is from negative 2 till 2. Now, is 1 in my domain? Yes, it is. Negative 1 is also in my domain, and 0 is also in my domain. Now, my final step is going to be what? I am going to draw a table. So 5, I'm going to draw a table. So this is the first derivative test, right? So draw a table. Now, what am I going to have in this table? I am going to have my x value. Okay, let me just take it one line down. So I have my x value. I have f prime of x, and I have f of x. Let me just fix my table first. Okay, so first thing I'm going to do is that I'm going to write my values of the domain at the end. So I have negative 2 and 2. Then I'm going to plug in my values for the critical points that I found. Now I'm going to mark this so you don't get confused. Now for this, I'm working with f prime of x, so I'm going to be working purple. What's my f prime of x? I'm going to write the equation down beside it, so if it helps you, write the equation down beside it so you don't substitute into the wrong equations. 4x cubed minus 4x. So any work I'm going to be doing in this row, I'm going to be substituting into this equation. Now, in f prime of x, all I need to do is substitute a value in between these two, each interval. So I'm gonna take a value in between negative 2 and negative 1. Let's say I choose, for example, negative 1.5. Okay? And I'm going to substitute negative 1.5 into this equation. I don't care about what value I get, I only care about its sign. And when I substitute any value in between negative 2 and negative 1 into my derivative function, I get a negative answer. Now I'm going to do the same in between negative 1 and 0. Let me choose a value in between. Let's say I choose negative 0.5. And once I do, I get a positive value. Again, I don't really care about the number, I only care about the value I have. Now I'm going to choose a value in between 0 and 1. I'm going to choose 0.5. I'm going to substitute it into my equation here, and I get a negative answer. Then I'm going to substitute another value in between 1 and 2. Let's take 1.5, and I'm going to get a positive answer. Now, so here in f prime of x, I'm only choosing values in between. So choosing, like, I'm just going to say between like this. So I'm choosing value in between my intervals. Now I'm going to move on. Okay, if it helps, let me just write the arrows. Okay, now for my f of x, I am going to do it with orange so I don't confuse myself. I'm going to write my original equation to know that I'm only going to substitute into this one. So x to the power of 4 minus 2x squared. Now what am I going to do in my f of x? I am going to substitute each one of my x's into the original equation. So when I substitute negative 2 into my original equation, I get 8. When I substitute negative 1 into my original equation, I get negative 1. When I substitute 0 into my original equation, I get 0. When I substitute 1 into my original equation, this one, I get negative 1. And when I substitute 2, I get 8. So now my table is done. So now what am I going to do? I'm going to analyze what I found in this table. So let me first start with the increasing and decreasing intervals. Alright, so this is from 4.3, which is the increasing and decreasing, but I'm solving for both. Yani one question, we're using both concepts, okay? So for increasing and decreasing, I'm going to be using my f prime of x. So I'm going to rely on these signs. So let me write here increasing, and I will write here decreasing. So it's increasing when I have the values, yani it has a positive in between the values. So whenever I see a plus in between those values, then it is increasing on that interval, and it's decreasing when I have a negative value in between these intervals. Now let me see where they have a plus sign. I have a plus sign here in between negative 1 and 0, so I'm gonna put negative 1 comma 0. Where else do I have a positive sign? Here, so it's in between 1 and 2, so it's also increasing on the interval 1, 2. Same thing for decreasing. Where do I see a negative sign? I see a negative sign in between negative 2 and negative 1, so I'm going to say negative 2, negative 1, comma. Always don't forget left and then right, okay? Then where else do I see a negative sign? In between 0 and 1, so I'm going to write 0, 1. So that's the first part of my solution done. Now the next part is that I'm going to be finding my extremas. So let me first start finding my absolute maximum. What's an absolute maximum? It means it's the highest value over the whole interval. Any absolute maximum is also a local maximum. So anything absolute, whether it be absolute maximum or absolute minimum, anything absolute is always local as well. So my absolute maximum, I'm going to look at f of x now. What is my largest value here? It's 8, right? So my absolute maximum is going to be equals to 8 at which axis? At x is equals to negative 2 and x is equals to 2. So these are going to be my absolute maximum, which is also a local maximum. Now let me see if I have an absolute minimum. So my absolute minimum is also going to be a local minimum. So anything absolute is also local, but the local is not absolute. I only have one absolute value. I cannot have more than one. Okay, so my local minimum, which is also here absolute minimum, so it's going to be equals to, what is the smallest value I have here? Is going to be negative 1 at which axis? At x is equals to negative 1 and x is equals to 1. So now I did something for this value, I did for this value, for this value, for this value. Now I have my 0. Obviously my 0 cannot be an absolute anything because it is, I already found my absolute values, my absolute minimum, my absolute maximum. I can only have one of those. So it's going to be a local. A local what? How do we find out? I'm going to take 0 and I'm going to see which values it's in between. So it's in between negative 1 and negative 1. 0 is bigger than negative 1. It's higher than the value surrounding it. Since it's higher, it's going to be a maximum. So I'm going to have a local maximum equals to 0 at x is equals to 0, and here we would be answering the 4.1 part. And that's it for this question. Okay, moving on to our next question. I'm given f of x is equals to 2x cubed minus 3x squared minus 12x plus 5 over my interval 0 to 3. So let's start solving like we did before. My first step is going to be saying that f is continuous over my closed interval and differentiable over my open interval. That's my first step done. My second step, like we said, is going to be finding the derivative of x, which is going to be 6x squared minus 6x minus 12. Now you can simplify this, but there's no need. We can just do it on the calculator in the next step. So my third step, like we said, is going to be finding my critical points. So CP, let's say critical points, which is going to be f prime of x equals to 0. How am I going to do that? I'm just going to do 6x squared minus 6x minus 12 equals to 0. And then I'm going to put mode setup 5, 3 on the calculator, not 4 this time because it is a second power. And once I do that, I'm going to get two values, which are x1 is equals to 2 and x2, which is going to be negative 1. Now don't forget we said the fourth step is to check if my x values belong to my domain. Now my domain is from 0 to 3. Does 2 belong to the domain? Yes, it does. 2 is in between 0 and 3, so yes. But negative 1 does not belong to my domain. It's not here, so I don't use it. Okay? So now my next step is going to be drawing my table. I have x, I have f prime of x, and I have f of x. Let me just fix my table. Okay, so first thing I'm going to do is I'm going to plug my domain. So it's gonna start at 0, it's gonna end at 3. What values do I have in between? I just have 2. Now I'm going to use the blue for f prime of x. So what's my f prime of x? It is 6x squared minus 6x minus 12. We can simplify it to f prime of x, like we said, we can simplify it to x squared minus x minus 2, so it can make my substitutions easier. Now, I'm gonna choose a value in between 0 and 2. Let's say I choose 1. I'm gonna plug 1 into my equation, and once I do, I get a negative answer. Then I'm going to take a number in between 2 and 3. Let's take 2.5 for example. I'm going to plug it into my f prime of x, and I'm going to get a positive answer. So this is decreasing and increasing. Now for my f of x, I'm going to be using another color so I don't get confused. So for f of x, I'm going to be substituting into my original equation, which was 2x cubed minus 3x squared minus 12x plus 5. So I'm going to substitute these values. When I substitute 0, I get a 5. When I substitute 2, I get negative 15. And when I substitute 3, I get negative 4. So now I finished drawing my table. And also if it helps, you can kind of like sketch the graph, just like this. Okay, so now let me analyze my data. So let me first take my decreasing and increasing intervals because it's easier. So let's get this over with first. So decreasing and increasing. So where do I have a negative sign? It's here. Which values is it in between? 0 and 2. So I'm gonna write 0, 2. For increasing, I have a positive here. So it's in between 2 and 3. Now I am going to take my extremas. So let me first start by finding my absolute maximum, which is also a local maximum. So every absolute is also a local, which is equals to, what is the highest value I have here? It's 5, right? So it's equals to 5 at x is equal to 0. So this is my absolute maximum. I can only have one absolute maximum and one absolute minimum. So then I'm going to check for my absolute minimum. Yani for the absolute, we're checking over all of them, not only the surroundings, throughout the whole group. So this is going to be also a local minimum, which is the smallest value over all of these. It's negative 15. So it's going to be negative 15 at x is equals to 2. Now I analyzed this one. I analyzed this one. Now let me look at my negative 4. Negative 4 the only value close to it is negative 15. Now, negative 4, is it bigger or smaller than negative 15? Negative 15 is larger than negative 15, so it's greater than its surroundings. If it's greater, then it's going to be a local maximum. Also, it's going to be a local anyways, but we only need to figure out if it's maximum or minimum. So I'm going to have a local maximum equals to negative 4 at x is equals to 3, and that's it for this question. Now I'm just given negative t squared minus 3t plus 3, and I'm given no domain this time. Since it is a polynomial and I'm given no domain, so my domain is always going to be all real numbers, which is from negative infinity to positive infinity. Okay, now let us start with our usual steps. So like we said, step 1, I'm going to say g is continuous over my closed interval negative infinity infinity, and differentiable over the open interval negative infinity and infinity. Now my second step is going to be finding my derivative, which is going to be negative 2t minus 3. And then my third step, like we said, is finding my critical points by making g prime of t equals to 0. When I do minus 2 minus 3 is equals to 0, let me solve for t. Negative 2t is equals to 3, divide by negative 2, divide by negative 2, I get t is equals to negative 3 over 2. Now I need to check, does it belong in my domain? Yes, it does, because my domain is all real numbers. So now let me draw my table. Now just one thing here, negative 3 over 2, if you want to make it easier for yourself, convert it to decimal so that you can fill in your table properly. So this is the same thing as is equals to negative 1.5. So let me start by drawing my table. I have, not x, I have t this time. I have t, I have g prime of t, and I have g of t. Let me fix my table. Okay, so like we said, I'm gonna start by plugging in the values of my domain. So negative infinity and infinity, and what value do I have in between? Negative 3 over 2, which is, let's start above it, negative 1.5, so that we know how to substitute. So my g prime of t, I'm going to use the grain for it, which we found to be minus 2t minus 3. I'm going to substitute a value in between negative infinity and negative 1.5. So let me pick, for example, negative 1.8. I'm going to plug it into negative 2 minus 3, and I'm going to get a positive answer. Now let me choose a value in between negative 1.5 and infinity, and let's say I choose 2. I'm going to plug it in, and I get a negative answer. Now let me move on to my g of t. I'm going to use purple for it. My g of t is negative t squared minus 3t plus 3. So I cannot substitute infinity into my function, so I'm just going to leave it as is. And when I substitute negative 3 over 2, I get 5.25. Now let me analyze my graph or my table. I have, let's first start with the increasing and decreasing. So it's increasing. Where do I have a positive sign? It's in between negative infinity and negative 3 over 2. So it's increasing over the interval negative infinity to negative 3 over 2. And when is it decreasing? It is decreasing over the interval. Here I have a negative sign, so negative 3 over 2 till infinity. Now let me take my absolute, like my extremas, but before that let me just do something here. I'm going to do this. It's always easier when we like make a little sketch of the graph. Okay? Wait, I did a mistake here. Okay, so this is going up, my bad. So this is going like this, and then it's going like this. Now, I need to find my extremas. So let me first see if I have an absolute maximum. Now my graph here, it goes from down, so from negative infinity, alright? So from negative infinity, and then it reaches the highest point here. So my highest point here, which is the largest value, is going to be my absolute maximum. So I have my absolute maximum, absolute maximum, which is also a local maximum, equals to 5.25 at x is equals to negative 3 over 2. So this is my first thing. Now, let me see, do I have an absolute minimum? So here I have infinity. So my graph is going, and هون it's infinity لتحت. So down, 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 down. And then it keeps going down to infinity. So in this case, I have no absolute minimum, no absolute or local minimum. So I don't have any of these. لأنه I'm down at infinity. يعني this is the highest point I reach, which is my absolute maximum. But in here it's going down infinity